Welcome! In this video, we will show how to generate, analyze, and design a Cofferdam model with DeepEX software. We will generate the model with the DeepEX Model Wizard. We start by selecting the preferred unit system. In the first tab, we select the desired analysis method, and we can edit the analysis options. In the second tab, we need to select the desired project type. We click on the button to generate a Cofferdam model, and we define the project dimensions and support properties. We can define parameters such as the final excavation depth, the wall depth, and the distance between the walls, as well as the top of the wall, the soil surface, and the water table elevations. We can edit the strut spacing and select one of the available sections. By clicking to edit the support, we can define the strut section type and size. In the Soil Layers tab, we can select to edit the soil properties and create a local database of soils. Then we can edit the boring and define all the required soil layers by defining the top elevation and soil type for each layer. In this example, we will use 3 layers: a fill, a sand, and a glacial till. In the Wall Type tab, we can edit the wall section properties. In this example, we will use a sheet pile wall section AZ19. In the Stages tab, we can define the elevation for each bracing level. In this example, we will use 2 levels of struts, one placed 13 feet and one 23 feet below the top of the wall. The DeepEX Model Wizard produces the model including all construction stages. We can review all stages, and we can select to analyze the model. When the calculation is completed, DeepEX loads a summary table with critical results and checks. In the model area, we can review several result graphs for each stage, including the wall moment and shear diagrams, support reactions, and more. In DeepEX, we can also include wave pressures. In this example, we will select to calculate the wave pressures with the GOTA method, and we will select a tropical depression wave from the implemented Coastal Engineering Manual. The analysis summary shows any overstressed element with red. On the model area, we can select to display the additional wave pressure graphs. We will add a copy of the wall section, and in the Analysis tab of the program, we will apply the nonlinear analysis method with soil springs. We assume as wall friction 33% of the soil friction angle for both walls. When the analysis is completed, we can see the results with a nonlinear method, including the wall displacement graphs, support reactions, pressures, and more. We'll add one more copy of the design section, and we will apply the finite element method. We will assume a fine mesh density. When the finite element analysis is completed, we can see all result graphs for each stage and also display the generated fan mesh and all displacements, settlements, and stress shadings on the model area. Thank you for watching this video. Visit our website for more insights.